Hello everyone, this is lecture 6 and this lecture is about effluent treatment. Okay, so during the fermentation process, uh, waste materials are produced. Okay, lots of waste materials are produced, and these waste materials include like unconsumed inorganic and organic media components, microbial cells, suspended solids, filter aids, cleaning materials, water wastes, etc. Okay, and the cheapest method would be if the industry can just directly dispose this waste into the nearby water body or the land source. But the problem is they cannot do that because it is dangerous for the environment. So why it is dangerous for the environment? Because if the I mean why? Because the fermented effluents, they contain high level of organic materials, and if these are discarded into the water, then they get oxidized by the microorganisms, and this process requires lots of oxygen. So what will happen, the oxygen will drastically get depleted, so that means it will drastically reduce the dissolved oxygen concentration in the water. Okay, and dissolved oxygen concentration is very important. A minimum level of dissolved oxygen concentration is very important for the living things of the water. Okay, so that means they will directly affect the living things of the water. Okay, they may even completely destroy the biodiversity of that water. Okay, so that's why almost all the countries nowadays they have guidelines, environmental guidelines. Okay, so where it is clearly stated that what kind of waste cannot be discharged into the environment directly, and what kind of treatment should be done before discharging the effluent into the environment. Okay, okay, so well, this slide actually just contains some additional information about the dissolved oxygen concentration. And you know, usually dissolved oxygen concentration used as an indicator of water quality, because for the well-being or the for the biodiversity to remain in their original form or the like unaffected form, the oxygen saturation concentration should be more than 90%. Okay, so that means if the dissolved oxygen concentration goes below 90%, it will affect the living bodies of the water. Okay, so that's why dissolved oxygen concentration is used as a indicator of water quality. So that means if the dissolved oxygen is less than 90%, that means that the water quality is bad. Okay, it's not good for the living of the living things. Okay, and there are different methods to calculate or to measure the dissolved oxygen concentration. One is BOD, biochemical oxygen demand. Okay, so BOD is a measure of the quantity of oxygen required for the oxidation of organic matter in water by microorganisms present in a given time interval at a given temperature. Okay. However, measuring the BOD, it takes time. It usually takes 5 days. Okay, so that's why an alternative, which is called COD, chemical oxygen demand, is measured. Okay, and the test by which COD is measured, it takes only few hours. Okay, so that's why what actually done, like basically people measure both COD and BOD, but initially they measure COD because it takes less time. Okay, then also they measure the BOD. Okay, so especially this kind of things is measuring COD and BOD is important for effluent treatment. Okay, okay. Now, so now we know that it's important to treat the effluent before discharging them or disposing them into the environment. Okay, so now which method will be used to do the effluent treatment, or what will be the approach to discharge the effluent? Okay, to make a decision about that, site surveys is essential. So A complete survey of industrial operations is essential for any individual site before an economical waste treatment program can be planned. Okay, so it is important. I mean, if we want to plan a economical treatment program. Okay, so treatment program means what kind of methods will be used to treat the waste and how the waste will be treated. Okay, so these are included in the treatment program. To choose a economical waste treatment program, we need to do a complete survey of all the industrial processes, all the industrial operations. Okay, and this survey may indicate a better control of water uses. It can identify sources of uncontaminated and contaminated water, and uh, the various wastes can be tested to access the best potential methods of treatment. Thus, this can prevent unexpected losses of finished products, solvent wastage, expensive use of water, or unnecessary contamination of water. Okay, so during doing the site survey, several factors need to be investigated. So, these factors, okay, like daily flow rate, fluctuations in daily, weekly, seasonal flow, the BOD or the COD, suspended solids, turbidity, pH range, temperature range, uh, odors and tastes, color, hardness, detergents, radioactivity, presence of specific toxins or inhibitors. Okay, so all of this need to be investigated during the site survey. Okay, and if the site survey is comprehensive, that means it covers all the industrial operations of that industry, then it will be possible to plan an overall treatment, like like the water source which can be reused or combined. Okay, so that means which water source can be used, or if we can whether if we can reuse the water. Okay, and concentrated waste streams which contain valuable waste to be recovered as food, animal feed, fertilizer, or fuel. I mean, all the waste products are not useless. Okay, so some waste products, they actually can be used as food, animal feed, fertilizer, fuel, etc. So when we'll be able to know that, when we will do the survey of that wastes. Okay, then if the some toxic effluents, they may need a special treatment. Okay, and the effluent loading expected under maximum production conditions. I mean, how much effluent can be will be produced when the will go when the process will go in its maximum rate. Okay, and some effluents can be directly discharged without any treatment. Okay, so by doing the site survey, we can also identify that which effluents we don't need to treat. So so if we can discharge some effluents without any treatment, it will be completely wastage if we try to treat them, right? So we need to identify those effluents which we can directly discharge. I mean, which will not be harmful for the environment. Okay, and some waste we cannot I mean, they discharge in the environment, but we can discharge into the municipal spheres. Okay, this also need to be this also can be identified by a comprehensive site surveys. Okay, okay, now effluent disposal methods. Okay, that means how the effluent can be disposed, or how different effluent can be disposed differently. Okay. So, okay, so the effluent disposal procedure of the methods which is finally adopted by a particular industry is obviously determined by a number of factors, of which the most important factor is the control exercised by the relevant authorities in many countries on the quantity and quality of the waste discharge and the way in which it might be done. Well, actually, different countries, they may have different regulations, different rules. Okay, so it's also the industry, they also have to understand those rules and address those rules. Okay, so anyway, the range of effluent disposal methods which can be considered are different, such as these are those: the effluent is discharged to land, river, or sea in an untreated state. Okay. Well, some country or some places of the, some state of countries, they may allow that. Okay. So they may allow the discharge of effluent directly to the land, river, or the sea. Okay. The effluent is removed and disposed of in landfill site or is incinerated. The effluent is partially treated on site prior to the further treatment or disposal by one of the other routes indicated. So, part of the effluent is untreated and discharged as in number 1 and 2, as defined in number 1 and 2, and the remainder is treated at a sewage works or at the site before discharge, and all of the effluent is sent to the sewage works for treatment, although there might be reluctance by the sewage workers to accept it. Okay, a negotiation is necessary then. It's also actually done by the sometimes negotiation between the company and the sewage workers. Here actually not the sewage workers, the sewage authority. Okay, negotiation is sometimes done. Sometimes also these are defined in the regulations. Okay, that, that whether the industry can directly discharge their effluent into the sewage or not. Okay. Okay, and all the effluent is treated at the factory before discharge. So all these methods, there are six methods that they indicated about six, mentioned about six methods. So these are the methods by which disposal can be, effluent can be disposed. So which method the industry will use? Okay, it will be determined by various factors. For example, what kind of waste those are. Okay, so what kind of this what I wanted to say, like whether if these waste they contain toxins, okay, like heavy metals, or like too much organic compounds. Okay, so these factors and also the regulations and guidelines of that country. Okay, so based on those, the industry they decide. Okay, so by which way they are going to discharge their or dispose their effluent. Okay, so if the country allow that, okay, you can just discharge all your effluent into the sewerage, they will do that, because it will be more economical for that industry. Okay, but sometimes the country may require that, okay, so you can discharge your effluent into the sewers, but before that you have to do this level of pre-treatment. Okay, so I think you already understand that it depends, which method of disposal will be used, it depends on the guidelines actually. Okay, well, so these were about the disposal methods. Now, where can the effluent be disposed? Okay, so that means the disposal sites where the effluent are disposed, can be disposed, like into the seas and rivers, lagoons, okay, like the oxidation ponds, spray irrigation, well disposal, landfilling, incineration. Incineration means completely burned them. Okay, disposal of effluents to sewers. Okay, well, among this one may look confusing. Spray irrigation. Well, some waste. Okay, so they may be. As I said, all the waste are not bad always. Okay, so some waste, they may be actually good for the cultivation. They can be used for the irrigation. So if in industry, or if it's proven that this waste, if it is proven that that particular waste, it actually help to improve the cultivation, they may be disposed, if they may be used as irrigation. Okay, okay, now the treatment process. Okay, we talked about the disposal methods and sites. Now treatment process. I mean, if we have to actually nowadays the environmental guidelines are very strict in most of the countries. So basically, at least some level of treatments, sometimes complete treatments, sometimes some level of treatments, they are required. Okay, so and there are different ways or process to treat the effluent, such as physical treatment method, chemical treatment method, and biological treatment method. Okay, well, these are the different ways or process by which treatment is done. But if we think about how the effluent are treated, well, actually, in most of the cases, the effluent cannot be only treated by physical methods or chemical methods or biological methods. Okay, so all these methods are used. That means when a complete treatment need to be implemented, all these methods are used in different stages of the treatment procedures, okay, or the different stages of the treatment program. Okay, so that's why the treatment process may also be described in the following manner, like the primary treatment, secondary treatment, tertiary treatment, okay, slash conditioning and disposal. So primary treatment can be done by physical and chemical methods, so for example sedimentation, coagulation, etc. Then secondary treatment. Okay, so secondary treatment is done by like biological methods, for example activated sludge. Okay, and secondary treatment is conducted after the primary treatment. Okay, so then the tertiary treatment, so after the secondary treatment, it can be done by physical, chemical, or biological methods. Okay, and this treatment is used to improve the quality of liquor from the previous stage. Okay, okay, and then the final stage of the treatment process, slash conditioning and disposal. Okay, this also can be done by physical, chemical, and biological methods. Okay, such as anaerobic digestion is often used to condition the sludge produced in the previous stage. Okay, and following dewatering. So first, like if anaerobic digestion is done to condition the sludge, then dewatering is done. Okay, so dewatering, what dewatering do, it removes all the water content from the sludge, so the sludge become dry. Then it's actually easy to discharge dried sludge. I mean the dry sludge just can be disposed by incineration or landfilling. Okay, okay, so that's all for this part. In the next part, we'll discuss about the this different physical, chemical, and biological treatment methods. Okay, so thank you for your patience.